So this is where we left off in our last video. Now I will be constructing 4 different devices with these 4 different absorber materials. So if you go back into the paper, let's see how the device configuration looks like. So they have added the PCBM at the top as the ETL material and Spyro at the bottom as the HTL material and peroxide material in the middle. So I will be constructing a similar kind of setup based on the data from this table. So let's begin inserting the data into our SCAPS software. As you can see, I have already inserted the data from the paper. So these are the thickness, band gap, electron affinity, and all the stuff already inserted. And this structure is inverted. As you can see, the light is going from the bottom. So I have added the ETL material in the bottom and the HTL material at the top. It's the same thing, but the lighting condition from the bottom. So we'll be setting the maximum number of iterations to the maximum limit, which is 1 with 6 zeros, and we'll be setting up the batch parameter. So for the material, it will be the peroxide material, the absorber material, and we'll be varying the thickness. And I use custom thickness list, which I already have saved that I'm loading now. So this is my thickness batch, and I will count the thickness from 0.1 micrometers to 1 micrometers, which is sufficient enough for our analysis. You can check what that particular paper did in their research and set it up again according to that as well. So update. So next we want to add defect variation. So add absorber defect, setting custom defect density. So these are the variations of defect I will be using, and we'll have to set the donor density variation, adding the donor density variation and shallow donor density, load. This will be the doping concentration batch. It is same as the donor density. Update. So these are the 3 parameters that we will be varying, and we would want to see how the PCE changes. So we will be suppressing the updating the UI every time each simulation runs. This will make this run faster and avoid any unnecessary crashes. So click OK, and the record setup, we will only be observing the efficiency. So we'll be inserting efficiency data, set OK, and we will start calculating the batch setup. This will take some time. As you can see, there are 800 programs in total, and it has started calculating each programs in the background. So I'll see you at the end of this run. So our batch calculation is complete, and we press the recorder and check show. These are the results. We will be copying them like this and all the way at the end, and you should press Ctrl C, and we'll be pasting them in our plotting software. Zoom this out a little bit. So in my case, the first absorber we measured was cesium lead iodide. So I will be only keeping cesium lead iodide, and I will just copy and paste those all the way down. And this is just an example I've done, but I've already created the full data set, and it will look like this. So cesium iodide has 300 dataset, and cesium lead bromide had 300 more dataset, and similarly cesium tin chloride and cesium tin iodide. And total I have 1200 dataset in total. This will be the input parameter, input dataset for our machine learning model. So all I have to do is export this as a CSV file. So set export ASCII and save it as CSV. And one thing you should consider is that only keep one heading and no units and no comments, and the heading should not contain white spaces. If you want to use two separate words, use underscores, for example. And similarly, only keep the long name. You don't have to keep these things. Export with full precision, and export missing data and missing values as dash dash. Uncheck this. So you only have to check include long name and export with full precision, and the CSV file will be exported into this folder. So click OK, and we will have exported into that folder. So I'm opening the CSV file to check it out. Well, there you go. This will be the input file for our machine learning model in Python. So I'll be doing that in the next video.